This is lab 1, the goal scaffold, and this lab is small on purpose. The goal is not to build a full Claude application. The goal is to prove that you can do 4 basic things. Open the course download pack, run local scaffolding, read a sample response, and explain the next safe action. There is the baseline this course needs. If this lab doesn't work, everything later becomes harder than it needs to be. Later lessons assume you understand the starter folder, the solution folder, the nodes folder, and the habit of using logs as architectural state. That last phrase, meta, logs as architectural state. In this course, logs are not just debugging noise. They are evidences. They tell us what happened, which branch ran, and what the system should do next. The scaffold provides 4 small things. First, environment values load from placeholder configurations. Second, the default recording path uses a sample response, so no real application programming interfaces key appears on screen. Third, the application routes one stop reason. Fourth, it logs usage and the next action. That is enough for the first lab. A stable local baseline lowers support cost because we can reproduce the same behavior every time. The solution also includes an optional live smoke check for later. But the main record path stays offline and deterministic. Every lab follows the same folder contract. The starter is where you work. The solution is the reference implementation. The nodes folder holds troubleshooting nodes and update nodes. Use the solution to understand the pattern, but do your own work in the starter. The starter is where you practice. The solution is where you compare. The nodes are where patchable details live. Now switch to course download pack. I'm going to do 3 things. First, run the starter. Second, inspect the intentional gap. Third, compare it with the solution. Start at the lab 1 README file. The outcome is a runnable local scaffold. It loads environment values. It reads a sample response. It routes a sample stop reason, and it logs usage and the next action. In the solution, it also prints a request skeleton. That request skeleton gives us a shared shape for later lessons. Now look at the starter. The starter says exactly what it does. It loads environment values, it reads the sample response, it prints basic routing and logging output, and it leaves stop routing implementation thin. That thinness is the point of the lab. We are not trying to finish the whole agent loop here. We are trying to see the layer where the control decision belongs. Now look at the environment file. This file is deliberately small. The key value shown here is placeholder, not a real credential. That is intentional. For the first lab, do not need a leaf service. We need a stable local trace. Now look at the sample response. The sample response is also deliberately small. It gives us a response identifier. It gives a stop reason of tool use. It gives us a text block, and it gives us a tool use block, and provides a token usage. That is enough to practice reading response state before trying any fix or implementation change. Before running it, look at the shape. The starter loads the environment file. It loads the sample response. Then it passes the stop reason into a tiny router. That is architecture pattern in input, response state, router, logs, next action. Now run the starter from inside the starter folder. The output confirms the environment. It confirms the sample response identifier. It confirms the next action. And it confirms the usage numbers. That is the baseline proof. The scaffolds run locally and it exposes the state we need to reason about. Do not rush past this output. This is not just terminal noise. This is the evidence set. It lets you say what happened. It lets you say which branch ran. It lets you say what should happen next. If you cannot explain the trace, you do not understand the system yet. Now look at the intentional starter gap. The router handles tool use, then it returns a to-do message for other stop reasons. That is enough for lab 1 because the point is to see the routing layer. The correct architecture habit is not to read assistant wording and hope. The habit is to route on response state. Do not ask the assistant text whether the loop is done. Ask the response state. What happened? That is the lesson. Now compare the solution. The solution adds a request skeleton that gives the course one shared shape for model, system instructions, messages, tools, and metadata. This is a learning scaffold. This is not the final application programming interface lesson. The solution also explains the routing branches. Tool use means run the request tool, append a tool result block, and continue the loop. And run means return the final answer and persist logs. Pause turn gets its own next action. Maximum token gets its own explicit next action. That matters because different response states do not mean the same thing. Different response states require different next actions. Now looks at the minimal functions. The main function turns these pieces into the trace you want to see while learning. Environment, request skeleton, response identifier, stop reason, next action, usage. Later we will make the loop deeper, but the evidence set starter here. Now run the solution. The first difference from the starter is that it prints the request skeleton. Request in, response state out, logs around the loop. Then the solution logs the response identifier. It logs the stop reason. It logs the 3 next actions for tool use, and it logs the usage numbers. Notice the order. We do not declare completion because the assistant texts sound helpful. We follow the response state. That is the architecture habit. Now, if the lab doesn't run, use the troubleshooting node first. The usual issues are simple. You may be running from the wrong folder, you may be using Python version that is too old, or you may have edited the sample file until it no longer matches the code. Do not guess randomly. Read the trace, check the folder, check the Python version, check the sample response, then compare with the solution. The update node is also part of the course operation model. The lab teaches the architecture habit, not a fragile live service moment. Now there is the exam lens. If a scenario says the loop checks whether assistant text contains the word done, the first fix is not stronger wording. The failure layer is a loop control, and loop control shouldn't depend on fragile text matching. The stronger answer is to route the response state and preserve enough logs to prove that happened. Lab 1 is small, but it gives you the first concrete example of architecture habit. It shows why the best answer is not always write a better prompt. Sometimes the best answer is move the control decision to the correct layer. That is the point of the gold scaffold lab. Before moving on, run both the starter and the solution once in your own course download pack. If both run, you have the baseline this course assumes. If they do not run, fix the local setup now, before later labs add more moving parts. Run the starter, run the solution, read the logs, explain the next safe action. This is the gold scaffold baseline.